Lagrange multipliers are a method for finding the largest or smallest value of a function when that function is subject to a constraint. The rule in words is this: the gradient of the function must point in the same direction, or the exact opposite direction, as the gradient of the constraint. In symbols, this rule is written as gradient of f equals lambda times gradient of g, where lambda is called the multiplier. Let's work through an example together. We want to find the largest and smallest value of the function f of x, y equals x plus y. This is subject to the constraint x squared plus y squared equals 8. On screen, picture this constraint as a flat two-dimensional circle drawn in the xy plane with radius equal to the square root of 8. Now watch the circle lift upward into 3 dimensions, becoming the boundary condition sitting underneath a tilted flat plane, which is the surface of our function. The maximum and minimum will occur exactly where the plane's flattest direction just touches the circle, so let's find those touching points algebraically. First, we find the gradient of f. The partial derivative of f with respect to x is 1. The partial derivative of f with respect to y is also 1. Next, we find the gradient of g, where g of xy equals x squared plus y squared. The partial derivative of g with respect to x is 2x. The partial derivative of g with respect to y is 2y. Now we set the gradient of f equal to lambda times the gradient of g, one component per line. The first component gives us 1 equals lambda times 2x. The second component gives us 1 equals lambda times 2y. Since both of these equal 1, that means 2 lambda x equals 2 lambda y. Dividing both sides by 2 lambda, we get x equals y. Now we bring in the constraint equation x squared plus y squared equals 8. Substituting I equals x into the constraint gives x squared plus x squared equals 8. That simplifies to 2x squared equals 8. Dividing both sides by 2, we get x squared equals 4. Taking the square root of both sides, x equals 2 or x equals negative 2. Since y equals x, this gives us 2 critical points, the point 2, 2 and the point negative 2, negative 2. Now we evaluate f at each point to see which is the maximum and which is the minimum. At the point 2, 2, f equals 2 plus 2, which is 4. At the point negative 2, f equals negative 2 plus negative 2, which is negative 4. So the maximum value of f is 4 and the minimum value of f is negative 4. Now for the check step, we substitute each solution back into the constraint to confirm it holds exactly. For the point 2, 2, we check 2 squared plus 2 squared equals 4 plus 4, which equals 8, so it holds exactly. For the point negative 2, we check negative 2 squared plus negative 2 squared, which is also 4 plus 4 equals 8, so it holds exactly too. Watch now as the two-dimensional circle and the three-dimensional tilted plane come together on screen, showing the plane just grazing the circle at exactly these 2 points, confirming visually where the maximum and minimum occur. So, using Lagrange multipliers, we found that f reaches a maximum value of 4 at the point 2, 2, and a minimum value of negative 4 at the point negative 2, both lying exactly on the constraint circle.